They've been talking about that for a long time, so who knows? Yeah, it is a desperate ploy. It won't work. Who did that I wouldn't have put in my 2020s bingo card. Sony Animation Studios being the shining light of animated films. That's insane. I mean, they made the Emoji Movie for Pete's sake. Who would have thunk that Sony Animation Studios would like be the it studio right now? That's wild to me. The what? I didn't even know that was happening. All right, we got some logarithms, which means we have pictures, right? Not that many at the start. I'll let the TV warm up while I read you the beginning, and then we will go from there. Don't sit and watch American Pickers. Nobody flipping cares. Watch the math. Math is mathing. Okay. What do we do? 2 through? Wow, that's crazy. Okay. Number 14 is 7 cubed equals 343. 16 is 3 to the negative 3, which equals 1 over 27. 18, 9 to the 0 equals 1. Excuse me. 20, log base 6 of 1 216th equals negative 3. Where am I? Here am I. Here am I. Log base 4, this is 22, log base 4 of 4096 equals 6. And 24, log base 25 of 125 equals 3 halves. 26, log base 4 of, I don't know why I'm, no, just kidding. Number 26 is negative 3. Number 28 is 3. Number 30 is 1/5. 32 is 1/2. 34 is negative 3. 36 is 3. Now we got some graphs. So let me flip the page, take a picture, put it on the telly. All right. There is 38. And there is 40. And 42. And 44. 46. And finally, last and certainly not least, 48 is there. What questions do we have?
32.
Sure. Boom. But that's okay because we're going to get some Brandon Sanderson adaptations. That's going to be great. And I think they're going to be good. That would be awesome. 32, he says. Log base 121 of 11. We need to evaluate it. So what should we do? Well, we should probably like put a little step in between there first. 121 to the x equals 11. Now we can get the bases to match, right? So how do we do that?
Make it x square, put it x or 2x, and then have 11 underneath.
11 squared is 121. That's true.
We can put a 1 as the exponent to the 11.
If it makes you happy, sure.
Then we can use the formula to get 2x equals 1. So we divide both sides by 2. Get x equals 1. Get equals x equals 100.
Why did you ask about this one again? Seems like you got it.
My brain just wasn't running right.
I see. What other questions do we have? 28 and 36, is that what you said? 46.
I was going to ask about 48.
Okay. So 28 is log base 6 of 16. Is that what you said, 28? Okay, now what? Great. 6 to the what?
6 to the x.
Equals 216. Okay, what now? 6 cubed. X equals 3. Okay. All right, and 36. No, 46. 46. I'm glad there's no Grace tomorrow. I need a break. I'm ready. I've enjoyed this Grace semester, but I need a break.
How are you doing, Mr. Sean?
Thank you. I'm glad that you're happy for me. Base 5 of x minus 4 minus 5. Is this logarithmic growth or decay? Where am I looking to answer that question? The base, that's true. It's growth. So what does the parent look like? Oh, that's all foggy. I didn't see anything. There we go. Better. Thanks for the fire, Mr. Anonymous. It is going to go up. Swoop. Drawn poorly, but something like that. How does this guy change le parent?
It goes forward and right, upward over, backward, back 5.
Nope.
Down 5 and to the right.
To the right 4. Inside is horizontal. The one with the X is horizontal, right? Outside is, and then down 5. Okay, so, and then nothing else changes, right? There's no dilation. So easy money. We need to build us a little T-chart, right? Okay, what now? Do we solve for 5? What do you mean?
You put 5 in for x.
5 in for x? Sure, why not? 5 in for x sounds great. F of 5. Log base 5 of 1 minus 5. What's log base 5 of 1? 5 to the what equals 1? 0. True enough. Whenever you have, all right, isn't this in this lesson, or is this is in the next lesson, isn't it? Where we get the properties of the things, the fancy ones, or is that in this lesson? I don't remember. Did we talk about that in this lesson? No. Yeah, that comes later. So you'll learn a bunch of special ones that go with the exponential ones. One of them is anytime the argument is 1, then it evaluates out to 0. That's always going to be true because in order to get a 1, the exponent is going to be 0 because anything to the 0 is 1. Does that make sense? Okay, good. So 0 minus 5 is negative 5. Well, the log, no, this whole, remember, so this is potentially a point of confusion. We see this here and we see this with trig stuff. It looks like a crazy mess, but this whole thing is a number. Just like this is a number, right? What does that equal? It's a 5. So this whole thing, even with the extra symbols, evaluates to 5. So this whole thing evaluates out to 0. So it becomes a 0. So this is 0 minus 5. 0 minus 5 is negative 5. So even though it's ugly, it all is one unit. It's all one thing. And it equals 0. Now another property of logarithms that you're going to learn soon is that if the argument and the base match, that equals 1, right? Because 5 to the 1 equals 5. So if we can make this match this, then this whole thing equals 1, right? So what would we have to make x be in order to make this into a 5? What minus 4 equals 5? 9. So we put a 9 in, then it is a function logarithm. Good catch, Mr. San YT channel. That is true. This is Algebra 2 class. That's what we're talking about. We're talking about logarithmic functions. Okay, so we put a 9 in. Then that would end up being f of 9. Log base 5 of 5. I keep doing that. Minus 5. These match. This whole thing equals 1. So then we've got a 1 minus 5. What is 1 minus 5? 4. Negative 4. You could try to get it to be 1/5, because then that would equal negative 1, right? It would, right? Log base 5 of 1/5. 1/5. 5 to the what equals 1/5? How do we get that 5 to change levels like that? What do we raise it to? Negative 1. So this whole thing would equal negative 1. So if we can get this to equal 1/5, then we'd be off to the races. So that one might be a little bit easier if we write it out and we draw it in our margin, right? X minus 4 equals 1/5. If we want that to equal 1/5, what do we have to do? Add 4. So x would have to equal 4 and 1/5, right? Now, I'm going to throw this out there. He, being me, is doing all this mess to get pretty numbers, right? Now, I'm gonna give you a bit of a secret. Later, and if you want to go learn how to do it right now, later in this unit, we're going to learn a way to, in your calculator that doesn't have a log base 5 button, calculate log base 5. It's called the change of base formula. And so if you want to take the time to learn that real quick, you can chuck whatever the heck you want in here and get whatever the heck ugly decimals over here you want on your calculator, and you're off to the races, and you've got your table, stick it in there, whatever. Okay? So
I'd love for you to to be thinking through this because this is useful to your brain. This is useful to you doing this. I would love for you to do it this way. This is what, if you have it in you to struggle through it and lock in and think through and wrap your brain around what's going on here, I would strongly encourage you to do it. You're a student from Sri Lanka. I knew all about this. Ask me a question. Well, I don't need to ask you a question because I'm teaching a class. Thank you very much, though, for the offer, but you're welcome to put in. I'm glad you've learned it already, but these people are learning it for the first time. So, I would love for you to wrap your brain around this, but if you're like, I just can't, like this one is wall blocking me, then go learn how to do change of base, shove whatever the heck numbers you want in for x, punch it in your calculator, get whatever the heck other numbers in there, and put some dots on the board. Next year, you're just going to shove it in a graphing calculator and push table. So, yeah, I said next year. You're not allowed to use a graphing calculator on these tests. I think I said that on the last one, but probably so. Yeah, you can use the side calculator on these. So, what was your question?
What are we trying to do in this? I know
We're just building a table like we always build a table. That's really what we're doing. We're just trying to get some dots that we can plug in. That's our goal, right? But the reason why we're doing this mental gymnastics of trying to think, okay, what can we get in here? Because then without a calculator we can get pretty numbers, nice integer numbers.
we're trying to make the log go away.
You're always making the log go away. Like if I shove my calculator, let me grab a random one. Grab a random one and grab a calculator. Do this. What's a random number that we could put in here that might be useful to graph? How about 0? That's easy, right? F of 0 equals the log base 5. What's 0 minus 4? Negative 4 minus 5. Actually, I think I picked a bad example, but we're about to find out whether I did or not. Maybe we're going to pick a good example. So if I use my little handy-mandy-dandy graphing calculator, because I wasn't really thinking about domain issues, but that's fine. And I go in here and I do the log of negative 4. Didn't automatically put a parenthesis in there. Must be in a weird mode. Divided by the log of 5, and I push. What the heck are you doing, machine? Enter. Yeah, that's what I thought. That's a bad example. Yeah, because domain issues. We'll learn about that later. Well, actually learn about that now. Why would putting 0 in there break this? What does the log function have that exponential function also has? Yeah, it can't actually be 0 because what? Because it has a what? And there's an A word. In an exponential function, the asymptote goes this way. In a logarithmic function, the asymptote goes that way. Where is the asymptote on our function? It's worth going in just like we did on exponential and going in and dotting that graph in there. It's at 4, true enough. So it would be worthless to put anything less than 4, which I did because I was talking and not really thinking about what number I was picking, right? So give me another random number. That's where the asymptote is. We're going to get an error again. 6 sounds great. We don't allow to use calculators in our exams. Yeah, we sometimes do, sometimes don't. Good for you. Calculators are a great tool, except when they're not. Okay, where was I? 6 sounds fine, totally fine. 6 is a good example. Okay, so f of 6. What is 6 minus 4? 2. So log base 5 of 2. Punch it in my calculator. It's annoying to me that I'm in a weird mode, and so I have to think about how to put it in the thing, but it's fine. If I do this, it'll be easier. Log, what am I doing? Of 2 over log of 5. Enter. So what I get when I punch this in, I get that this is approximately equal to 0.43. So The point to answer your question is we are always trying to get rid of the log. We're not really getting rid of it, we're evaluating it. Just like the square root example, we're not getting rid of the square root, we're evaluating it. Right? So same here. Does that help with the answer to your question?
Like if it would be like 5, and then make a 1, and 5.
If this whole thing, if this is 5, yes. Because if the base and the argument match, then it's a 1. The whole thing is a 1. Because 5 to the 1 equals itself. 5 to the negative 1 equals 1/5, which is why we're doing this one. Right? So, if we put 4 1/5 in here, we get 1/5 and 1/5 and 1/5 in here, and we get 1/5 in there. Log base 5 of 1/5 equals -1, and then minus 5. What is -1 minus 5? -6. Now, since we know what this looks like, this is probably plenty of points to get to where we're trying to go, right? We know it's going to be something like swoop, right? So let's plug these in and see what we've got. So we've got 1, 2, 3, 4, 5, and then -1, 2, 3, 4, 5. So put a dot down here. Why on earth did I put it way down here? Maybe I wanted to work my knees today, I guess. Maybe I subconsciously thought that would be a good idea. Consciously, I'm not so thrilled about it, but it's fine. We go over 5, 6, 7, 8, 9, then down 4. So here. Right? And then we go over 4 1/2, or 1/5. So like right there. 4 1/5. And we get down 6. So like right at here-ish. 1, 2, 3, 4, 5, 6. So it's doing exactly what we expected. It is swooping this way. Right? Easy peasy. Question. I know physics is intuitive like math, so I was wondering how you would study physics because no matter how much I study, I seem to mess up on the exam. Okay, if you're still here, here's real simple answer to your question while I erase this board. Are you ready, internet man? Okay, so best advice I can give you on physics in a tiny amount of time. There's all kinds of stuff I can tell you about physics, but one of the best advices is this. Are you ready? If every single word problem, if you will write down what your given is with the units, then all you have to do is match that to what formula matches that, and then plug it and chug it. There's more tips I could give you, but that one, about 80% of the time, if you will do that consistently, you will have a better result in physics. That's advice for any of you who are currently in physics or will be soonly. So, what other questions do we have about logarithms? 48, she says. Yeah, we're doing good, even with the minor rabbit trails. Do you want me to punch you in the throat? For legal reasons, I'm joking. Good, you should be concerned. Oh, that's funny. F of x equals -1/3 times the log. Base 1/6 of x plus 2 minus 5. Okay, so we start with our frame of reference for what this looks like. What exactly am I teaching? Maybe you've answered, I don't know whether that's been answered or not. Teaching Algebra 2. Logarithms. Great. Continuing on. Which parent function is this? Is this logarithmic growth or is this logarithmic decay? This is decay. How do I know? What is it? The base. The base is less than 1. It's decay. So the decay parent function looks like what? It's going down, right? Like that. Asymptote here. Now, how does this change the parent function? So it goes to the left 2, and then it goes down 5. It's compressed, actually, because of the 1/3. So it's compressed, which we'll deal with the table. There's one more thing that happens that is important to note. What's the one more thing that happens on this one? We already got that. Asymptote moves with here. There's one that you were starting to say, but then you didn't, because as I started talking about the 1/3 being compression. What? No, it's not compressed and stretched, but it does something. It does flip. It does flip vertically because of the negative, right? So instead of being like this, it's going to be like swoop, right? Still has an asymptote here, but it's going to be like swoop, and it's going to move this way and that way. So now that we know what we're expecting, let's build us a table. Okay? Okay. What numbers do we want to put in for x? What numbers will give us pretty numbers? 6 will give us a pretty number. I don't think 6 is going to give us a pretty number. 4 is going to give us pretty. Isn't it 6 to the 15th? I don't really know what you're asking because there's a delay. Sorry. So 5, if we put in there, we get 5 plus 2 equals 7. And how is that going to make us a pretty number with a base of 1/6? What? Okay, so stop just saying words. Let's think for a second. 4 is a good option. Why is 4 a good option? Because it makes 6. That's true. 6 is related to 1/6 how? Reciprocal of it. True enough. So it's going to give us what answer? -1. True enough. So 4 is a great idea. So f of 4 is going to be useful. Let me put this down here. I'm going to refer back to it later. F of 4 is a great idea. So at -1/3 times the log base 1/6 of 6. What is the log base 1/6? I hate that word, it's terrible. Of 6. -1. True enough. What is -1 times -1/3? 1/3. What is 1/3 minus 5? -4 2/3. True enough. 4 2/3. -4 2/3. So once making the argument 6 is useful, what else would it be useful to make the argument into? What about 1/6? Right? That's, again, might be useful for brain to brain. You could potentially do that in your head, but just it's not going to take you more than half a second to jot it down. X plus 2 equals 1/6. Solving that, what do we do? Subtract 2, so we end up with x equals negative what? 1 5/6. True enough. Okay, so if we plug that in for x, f of -1 5/6. So negative almost 2, right? When we go to graph it with our scale, right? That's our what we talk about. All right, so we've got -1/3 times the log base 1/6 of, that evaluates out to 1/6. That's where we got that from, right? What is log base 1/6 of 1/6? 1, true enough. So 1 times negative 1/3 is negative 1/3. What is negative 1/3 minus 5? Negative 5 and 1/3. Negative a little bit more than 5, right? So negative 1 and 5/6. And negative 5 and 1/3. It would probably behoove us to get one more number in here. Oh, I meant x equals 6 to the 15 minus 2. Well, I have my chem finals. Good luck on your chem finals. You're probably already gone, but good luck. Okay, so what other number could we put in there that might be useful? What? What other, and by what other number would make this pretty? What could this be and I get a pretty number? Log base 1/6 of 12. So 1/6 to the what equals 12? You're thinking multiplication. You need to be thinking squares and cubes and all of that stuff. 32, sure. If we got it to be 32, that could be useful. So let's see what we'd have to put in for x to make it 32. The log, no, lies. What am I doing? X plus 2 x plus 2 equals 32. That's a good question because 6 cubed isn't 32, it's 36. Yeah. How about 36? Well, 6 squared is 6. Yeah, 6 squared, yeah, is, yeah. Why did I say cubed? Squared, yes, not 32. Great. What should we do? Subtract 2. So x equals 34. So let's plug 34 in. So way out here, this will easily be plenty, right? So if I plug 34 in here, we end up with 34. We end up with log base 1/6 of 36, right? Because 34 plus 2 is 36, minus 5. So log base 1/6 of 36 is what? No. Negative 2, because it changed levels, right? So it went from 1/6 to 36. So negative 2. What's negative 2 times a negative 1/3? Positive 2/3, right? Minus 5. What is positive 2/3 minus 5? Negative 4 1/3 and 1/3. We got plenty to be doing, right? Okay. Especially since we know what we expect, right? So asymptote is at negative 2. 1, 2. I feel like negative 1/6 would have been a more useful thing to try to get as our third point, but that's fine. Because this one is dumb. All right. So 4 and negative 4/3. 1, 2, 3, 4. And negative 4 and then actually almost 5. 2, 3, 4, 5. So right about here. So far it looks great. And then negative 1 and 5/6, 1 and almost 2, and negative 5 and a bit. One, 2, 3, 4, Oh, 5 and a bit. Okay, good. Sorry. Brain was broken for a half a second, but I'm back, baby. Here we are. And this one is way the heck over here. So it looks like this. And that's good enough for us. Which is what we expected from the beginning. We do have time for 1 or 2 more questions, potentially. Didn't we already do 36? We did 36. Yeah, we did do 46. I thought you had said 36, but then it was actually 46. All correct. We're back to the quote, unquote, easy ones, which is good by me. You know, that is one of those phrases that is often misstated, because people will very often say, I have done it many times myself, quote, unquote, but that is incorrect. The phrase would be, quote, unquote. Unquote is a single word. Brother, you need this one after we just did 1/6 ones? Bro, that's crazy. But we got you. Log base 1/6 of 1/216. Now, pause, freeze, don't move, not an inch, not a muscle, don't grab the calculator, don't do nothing. Is our answer going to be positive or negative? Positive. How do I know? No, not because they're positive. False. Yeah, you're in the right thing, because the 6 and the 216 are on the same level. They're both in the denominator, so it didn't flip. If we had 216 in here, then and 1/6 here, we're going to get a negative as our answer. We can change it to exponential form, which sounds great. 1/6 to the x equals 1/216. Great. So 1/6 to the what equals 216. I am doing well, Daniel. How are you? I don't know if these people are doing well. They're working on graphing logarithms, which is brain stretching when we first do a thing. Yes, sir. 6 to the third is 216, which means 1/6 to the third is 1/216. What were you going to ask, Stephen? Yeah, if you want to deal with all the negatives later, yeah. Because the negative divided by negative is positive, yeah. If that helps your brain get there, go for it. 1/6 to the third, x equals 3. Uncle's your Bob, which weirdly sounds almost inappropriate. It doesn't really mean anything, but it sounds very strange. All right. What other questions do we have from this lesson? Well, in that case, I think I am going to actually let you go early today. You should go study starting now. It's a good idea. No, we don't have a test next time. Don't look at me like that. But if you start studying earlier, it will help. This graphing bit isn't actually that hard, but it is hard at first to wrap your brain around. So wrestle with it. Ask more questions later if you need them. We'll see you on the Tuesday. Encouragement, whoever you are. We do have class in math class next Thursday.